Hello, and welcome to Reimagined Floodplain Elevations, a web developer perspective, presented by Kitty Hurley and Jessica Schuler. Hi, my name is Kitty Hurley, and I am a senior GIS developer and team lead at Minnesota IT Services, partnering with the Department of Natural Resources. I have over a decade of expertise in GIS, ranging from administration, analysis, and development. I specialize in web accessibility, UI, UX, web frameworks, and front-end web development. Additionally, I hold a Bachelor of Arts degree in Geography and in Individualized Studies from Gustavus Adolphus College and a Master of Science in Geographic Information Science from St. Mary's University of Minnesota. In my free time, I enjoy visiting Minnesota state parks, playing hockey, hiking, paddleboarding, and canoeing.
Hello, I am Jessica Schuler, and I am a GIS data steward and application developer with Minnesota IT Services, partnering with the Department of Natural Resources. I work with the Parks and Trails Division to manage technical spatial data, such as state park trail and road data. I develop custom web mapping applications using a variety of technologies and data resources for both internal and external users to interact with division or agency data. I hold a Master of Science in Geographic Information Science from St. Mary's University of Minnesota. Outside of work, I serve as a board member for Eagle Bluff Environmental Learning Center. I enjoy camping, hunting, adult recreational hockey, and gardening. In early 2021, we were sent a project request to fulfill 14 enhancements to an existing project, totaling in 367 hours, including adding additional map layers with a transparency slider, printed reports, analysis tools, and much more. Essentially, everything and the kitchen sink was asked of us.
With our list of enhancements in hand, we started off in mid-April and had to complete the project work before the end of our organization's fiscal year end, or July 1st. We had 50 working days to complete the enhancements. Well, actually, due to our previously scheduled time off and holidays, we were down to 38 days, or 304 hours. Now, remember that list of enhancements and the estimated time that Jessica mentioned? The list of tasks were estimated at 367 hours, so we had less available hours than the estimates provided. So now Jessica will dive into how our leadership team, project team, and how we approached the project to set ourselves up for success.
As Kitty mentioned, we had limited time available to us, so it was imperative that we looked for new methods to successfully execute the project on time. Our leadership team, project team, and we decided to work together, leveraging pair programming. Pair programming is an agile software development technique in which two developers work together. One writes code while the other reviews each line as it is typed in. The developers switch roles frequently. By approaching the project as a team, working through paired programming together, we were able to learn different styles and approaches to problems while addressing our task list within our project's timeline.
With our paired programming approach ready to go, we needed to dive into the project and learn what was previously completed and where we needed to go. Prior to our initiation into the project work was completed by another developer in 2019, with multiple projects and maintenance requests throughout the project's history. While the project had a lengthy history, there was a lack of documentation, so we had to read in between the lines to get at the most pertinent information, such as where data and content was stored, what code was being executed and where, and what was deployed on our server stack. The code itself was written in vanilla JavaScript, leveraging the Esri JavaScript API version 4, and made use of Portal web maps and data views hosted in Portal.
With the project's history in mind, we had a few questions. such as how can we gather insights on this project to manage the existing code, maintain existing bugs, expand on the work that has been done, and all of this while on a short timeline.
With the questions that Jessica outlined, we came on an opportunity as the developers of the project. We could not just identify the existing bugs, as you see us doing here in this photo, or troubleshoot through the code base, but instead work collaboratively to rewrite the application using a modern web development framework, in our case, AngularJS. Importing over the existing functionality with the Esri JavaScript API version 4, we could further understand and troubleshoot any existing questions from our customers, while also addressing the new functionality that they were seeking. So how can we put it all together?
On previous project, we'd receive emails with multiple Microsoft Excel and Word documents attached to the message. As developers, it was hard to discern what it is we had to do. And with a short timeline and two of us to sort through the information, we knew we needed to adapt and leverage new strategies.
So how could we adopt a list from a few Microsoft Excel documents and interpret them? First, we broke up our task list of 14 items. Then we assigned each of the tasks to one or two members of our project team at most to be assigned the task and lead the task through its effort. With this in mind, we were able to keep our task list low, with 3 to 5 tasks assigned across our team. We were also able, in consultation with the project team, able to identify optional tasks that we would likely be unable to tackle in this project cycle due to our short timeline and resources that were available to us.
For our first project resource, we leveraged Microsoft Teams. From the list of 14 tasks and with consultation from the project team, we were able to separate out our list into three categories: critical, preferred, and optional. Instead of leveraging Microsoft Excel spreadsheets to track our progress, we created a planner in Microsoft Teams in the projects team channel using buckets for the three categories. This method allowed everyone on the project team direct access to each individual task, and they could see the progress, our comments, and follow up through the shared team. Additionally, in Microsoft Teams, we leveraged weekly status video meetings, as needed video calls, screen sharing, and shared our final documentation in a Microsoft Word document in the Files section.
For our second resource, we leaned on another Microsoft product, Visual Studio Code, to assist us with our paired programming approaches. Through Visual Studio Code, we leveraged branching for features and tasks, merge requests and conflicts through Visual Studio Code's great interface to identify and fix any conflicts from our feature branches into the main branch. A linter so we had consistent coding standards between ourselves, consistent code comments, and continuous contributions to the project's README Markdown file.
For our third and final resource, we leveraged our organizational GitLab account. Using GitLab, we were able to successfully manage merge conflicts between branches, identify issues identified through testing, preserve the existing version 1 application and all of its contributions in its own branch, implement project documentation using a markdown file, and leverage tags to give a snapshot of deployment versions.
With our resources set up, let's get back to that rewrite. We knew we had our infrastructure in ArcGIS for Portal with Portal Web Maps and services hosted on Portal. So we continued to build on the existing infrastructure by adding additional layers into the web maps and editing the pop-ups using Arcade. Also, remember when we mentioned we were going to transition from vanilla JavaScript to a more modern web development framework with Angular? We needed to port over the existing application's content to fit the Angular web framework, while also tackling our new list of enhancements. In the transition from vanilla JavaScript to Angular, we were able to make incredibly large strides to the interface in the usability and accessibility enhancements and overall speed and performance improvements. Earlier, we also mentioned the lack of documentation on the project. So we kept that in mind while designing to ensure we documented the project for the next developer or developers. Next, Jessica will show us what the application looked like prior to our work and what that looks like today.
In version 1 of the application, we had one layer displaying lakes in the map. We didn't have many analysis tools available to us. Our list of enhancements asks us to add these in. For logged in users, the two tables were presented in the bottom of the application, which takes away from some valuable screen real estate. Table records were also edited in a separate pop-up window. After completion, version 2 of the application now contains many data layers. Usability improvements, including widget highlighting on selected widgets depicted with a green background on the widget icon. Logged in users will now notice the tables stacked top and bottom in the right-hand side of the application, giving more room for the map and interaction. Individual table records are edited inline if the user has permissions to view and edit the data. New table records are added via a separate pop-up window. Existing table records that are sought for deleting prompt users before deleting the records.
In addition to the application's parity with version 1, we had 14 enhancements to add in, including customized arcade pop-ups, a layer list with individual layer transparency, and 2 detailed reports that Jessica will dive into next.
As Kitty mentioned, we delivered 2 new custom printed reports in the application, including a map report and a basin report. The map report allows a resident or DNR staff member to select their area of interest on the map, and a PDF will generate with the map's layers, sources, projection, and the date of publication. Additionally, the basin report will allow a resident or DNR staff member to select a basin on the map, and if multiple exist, select the basin from a drop-down menu to generate the elevation report for the selected basin as a PDF. The report contains floodplain elevations in feet, information about the study, and DNR lake elevations.
Earlier, we mentioned we were being diligent to document our process throughout the design of the application, and we ensured we documented the key takeaways from the project, which included the repo setup, the project history, code history, future project recommendations, project infrastructure, key relationships, and data dependencies. Most importantly, we found the project infrastructure and key relationships for this project to have the most bearing for future developers and the project team. The project infrastructure includes ArcGIS for portal web maps, portal hosted services, and print services. Instead of having developers comb through the code, the project team can now leverage the README markdown file to get at the information. Additionally, we had key data relationships that are the foundation of the application for the basins, studies table, and elevations table. We documented the key relationships in a table format to provide visual feedback to the project team today and in the future project requests.
While we presented to you from a developer perspective, there were many colleagues on the project team, and we were thankful for their passion, involvement, and guidance throughout the project lifecycle. In particular, we wanted to thank Andrea Bergman and Zeb Thomas for their expertise in the project, and our other stakeholders for support in taking new strategies and approaches and to make the project feasible. Thank you for attending our presentation this afternoon. Have a good day.